Hey guys, welcome to Unit 5, Lesson 4. Our topic today is properties of limits. So pause the video and try the warm-up. The warm-up says find each of the following limits based on the given function. So a function is given to you, so you always start with direct substitution. If that doesn't work, then you think about either factoring, rationalizing, or simplifying, any of those things. So here, if I substitute -2, I do not get a denominator of 0. So I'm good to go. So I'm going to do -2 square minus 4 times -2 over -2 minus 2. So what do I get? I get in the numerator, it's 4 plus 8, which is 12, over -4, which is -3. The next one, limit as x approaches 1. If I substitute 1 in here, I do get a denominator of 0. So what do I need to do? Can I factor it? See, so yes I can. So limit as x approaches 1, I'm going to factor out the what? GCF 3x, and I'm left with x minus 1 over x minus 1. And what happens to my x minus 1? They cancel out, and now apply the limit, and this would be what? 3 times 1, which is 3. Okay, so now graphically, so limit as x approaches -1. So anytime you're looking at the graphs, you want to see if the left hand limit or the left-sided limit is equal to the right-sided limit. So I'm going to write that left-sided limit equals right side limit, so the limit exists. If it does not equal, then it does not exist. So as it's approaching -1, let's trace it. This is -1. What is it's approaching 0, right? And now if I trace from the right, as it's approaching, as my x is approaching -1, it's approaching what? 3. It's not the same, right? So this does not exist. D. So here we have a piecewise function, and it is asking us to check whether limit as x approaches -1 f of x exists or not. So what we're going to do is we have -1 over here in this function and here. So we're going to find both of them. This is what? This is basically limit as x approaches -1 from the left, because it's less than. So the first function we're going to use for the left limit, right? So I'm going to write the negative. So which would be what? X square, apply the limit, and you get what? -1 square, which is 1. We're going to do the same thing, and I'm going to do this. This is from the right, right? So limit as x approaches -1 from the right of f of x. And basically, you're just substituting in, right? -1, so -1 plus 6 over -1 square minus -1, right? So in the numerator, you end up with 5 over 2. So look here. So from the left, we had 1. From the right, we have 5 halves. Are they both same? They're not same, so the limit does not exist. Pause the video and try the second part. So anyways, let's do this. We're going to be using the second and the third function here. Limit as x approaches 2, because our 2 is over here, right, in the second and third function. So I'm going to check whether the left and the right limit are the same. So 2 from the left. For the left, I'll use the first equation, x plus 6 over x squared minus x, which is 2 plus 6 over 2 squared minus 2. So it's 8 over 2, which is 4. Let's try the next one. 3x minus 2 from the right. That's the graph from the right. 3x minus 2. I'm going to substitute in 3 times 2 minus 2, which is 6 minus 2, which is 4. So look here. Your limit is the same from the left and the right. So the limit exists, and it is 4. So that's your final. Let's get started with the lesson. The lesson today is properties of limits, and why do we need them? There are 6 basic facts about limits that can be used to calculate unfamiliar limits from limits we already know. So I just want to you to read through them, and then I'll summarize them real quick for you. Suppose that c is a constant and the following limit exists. So that we're saying both the limit exists. Then if it's addition, you can write it as two separate things also. If it's subtraction, you can do the same. C is the constant, right? So you can bring the constant to the front and take the limit of the remaining function. If it's multiplication of the two, you can multiply them separately. Once you find the limit, you can just multiply their answers. Same thing goes for division, and this one is also very important. A limit of a constant is just that number. So when we do the question, these will make more sense. Use the limit laws to evaluate each of the following limits if they exist. Again, the same rules apply though, okay? So if limit as x approaches 4, f of x is 0, and limit as x approaches 4 of g of x is 3, find, so what are we doing? Remember, there's a constant, so can I rewrite it as 2 on the outside? Limit as x approaches 4, f of x plus, I'm doing two things at the same time, right? I'm applying number 1 and 3, right? That's what I'm doing. It's just a combination. Limit as x approaches 4 g of x, right? So now, what is this part? This I know is what? 0. So I'm going to write 2 times 0 plus 5 times, what do I know about this part? This is, actually, can't see. It is 3, so 2 times 0 is 0, plus 5 times 3 is 15, so 0 plus 15 is just 15. Right, so that's your answer. Similarly, for b, I can separate it. Limit as x approaches 4 of g of x plus limit as x approaches 4, I wrote plus 4, I don't know for some reason, as x approaches 4 of 3, right? What do I know about this limit? I know this is what? Just 3 plus, what's the limit of a constant? It is just the number, so it is 6. Yes, so now let's try the next one. Again, what can you do with the negative 3? You can bring it out. So I'm going to rewrite it as negative 3 limit as x approaches 4 f of x times limit as x approaches 4 g of x, right? Because I know these individually, I don't know them all together. So I can do is, I'm just going to switch colors so that we get this. Negative 3, I know the first one is just 0 times 3, 0 times anything is just 0. The last one, it's division, so I can separate all of this. I can rewrite this as limit as x approaches 4 g of x in the numerator over limit as x approaches 4 f of x minus limit as x approaches 4 of negative 1, or just, no, sorry, 1. I just put that. It wouldn't have really mattered, so that's okay. So what is it? The numerator I get 3. I know that is 3. The limit as x approaches 4 of f of x is 0 minus 1. Limit of a constant is just that. So it's what? Negative 3. So this is how you do these questions. So now let's do one with the graph in there. Okay. So now you are given two functions here. The f is the red one and the g is the blue one. I know on your paper it might not be clear, it's all black lines, but it says f right here and it says g right there. Okay, so let's start with the first one. I'm going to break it out. I'm going to rewrite it. So limit as x approaches negative 2 f of x plus 5 limit as x approaches negative 2 g of x. Right? So what is limit as x approaches negative 2? First we have to find that. So let's trace it. When my f function is approaching negative 2, see it's continuous when it's, my bad, that was -1. It's from the left when it's approaching 1. From the right also it's approaching 1, so it is just 1. Right? Plus 5 times, let's look at the g function at -2. At -2, it is continuous, right? So it is what? Approaching -1. So this is what? -5 plus 1 is -4. Similarly, limit, I'm just going to erase this so we can keep writing over it. Limit as x approaches 1 of f of x times limit as x approaches 1 of g of x. So now I want to find them individually when x is approaching 1 for my f function. So let's trace it from the left. From the left, it's approaching 1. What's my corresponding y value? It is 2. If it is approaching from the right, is it approaching the same thing? Yep, it is approaching the same thing. It is also approaching. It's approaching 2, so that would be 2. And limit of g of x as x approaches 1 is what? When this is approaching 1 from the left, my y value is what? -2. And when it's approaching, I'm going to change colors actually. This is my g function, right? From the right, my corresponding y value is what? -1. -1 and -2 are not the same, so this is what? Does not exist. So this is basically does not exist. This limit does not exist, right? I just wanted to highlight a fact here. Like if I was looking at these functions, right? So if it's a continuous function, especially for when limit as x was approaching 1 of f of x, it's continuous. It's not breaking in between here, right? That limit does exist. If there's a break, if you have to lift your pencil to sketch the graph, then chances are the limit will not exist. Chance it's for real, but you should check it again, but that's what it is. Okay, the part C. So let's first rewrite this. Limit as x approaches to f of x over limit as x approaches to, I'm going to write the 3 here on the outside, g of x plus limit as x approaches 2 of 1. So now, as x is approaching 2, what's my y value? Again, it is continuous here, right? Do you see that? From the left, when x is approaching 2, this is my y value. Oops, I should use a pen. This is my y value. It's like a 1.5. From the right also, if I trace it, it's approaching the same number, 1.5, right? Approximately. So that is 1.5 over, now let's do that, 3 times, what is it? G of x. So I'm going to take a different color so that we can see it. So from the left when it's approaching 2, it is 0. From the right when it's approaching 2, it is 0. So it's going to be 3 times 0. And the limit of a constant is just a constant. So this would be actually 1.5. So finish up the remaining practice problem.